Welcome back to the tutorial session of bode plot. The previous section we have studied to draw the bode plot. The first part of bode plot, that is magnitude plot. The second part is phase plot is still remaining. So in this session we'll discuss about phase plot, how to draw the phase plot in the similar graph set. So till now we have studied to draw the magnitude plot of bode graph in a semi-log graph set. So we'll continue from here. Now to find out the phase plot, first of all we find the angle of the given transfer function from equation number one. You see the equation number one, g of j omega. Already we have 1000 after putting s is equal to j omega, and j omega 1 plus 0.1 j omega 1 plus 0.01 j omega. From this equation number one, we'll find out the angle equation will be angle of g of j omega is equal to minus 90 degree, because 1 by j omega and angle contribute minus 90 degree. 1000 because there is no imaginary axis here, so it does not have any angle. It will give 0 degree angle, so that's why no contribution of it. So for this term we have minus 90 degree. 1 divided by 1 plus 0.1 j omega, it will give minus 90 degree 0.1 omega, and for this part it is minus 90 degree 0.001 omega. Now we'll draw a table with this variable, yeah, various value of omega. We'll put the various value of omega here, and we'll find out the angle accordingly. So let's see here the frequency value, omega value we are putting here, like 1, 5, 10, 50, 100, 20 and 500, and correspondingly we are finding angle of g of j omega in degree. So now look at here, if we will put omega is equal to 1, so what will happen? Minus 90 degree minus 10 was 0.1 into 1, minus 90 degree 0.001 into 1, and we'll get angle minus 95.7 degree. Similarly, if we'll put 5 in the previous equation, it will be minus 90 degree minus 10 was 0.1 into 5 minus 10 was 0.001 into 5, and will get minus 116.5 degree. So you may consider it is 96 degree, you may consider this one is 117 degree. If we'll put omega value 10, then we may get 135.63 degree, that is nothing but you can consider it 136 degree similarly. So the confusion and question will come into your mind that how this omega value will be selected. Actually, I'll suggest you to put the omega values in such a way, select this omega value in such a way that the minimum value of angle should be approximately 100 and 110 approx, and the maximum value should be more than 180 degree. It sometimes if will be even though you'll be putting more number of values, then also you won't get 180 degree. So minus 1 degree actually, then in that case you just leave it. Otherwise you select omega in such a way that minimum value should be near about 100 degree, and the maximum value it should be near about 180 degree, more than 180 degree. So this is the way to select the omega value. We put this omega value in this equation number 2, and you get corresponding angle here. Now look at this semi-log graph. Already we have plotted this magnitude plot, minus 20 degree per decade and minus 40 degree per decade and minus 60 degree per decade. So, and we have discussed also how we have drawn this one. Now in the same graph sheet you will draw the phase plot also. So how to draw it? What we'll do, in this side we have taken magnitude in dB, okay, and in this horizontal axis we have considered this is frequency in radian per second. So opposite to this magnitude term, and in this corner what we have done, we have considered angle in degree, okay. Why we have considered this side? Because if we'll put same side, so it will be the overlap of that magnitude as well as degree. So what we have done, we have just considered this side, this corner of semilograph sheet as a angle, and it is in degree. So how we have selected this degrees value? So because we have maximum minus 205, that means approx 206 degree, and the minimum we have minus 95 or 96 degree. So we'll substitute such a way that the maximum value will be near about minus 200 and the minimum value should be near about 90. So I had started with minus 220 degree. It will be in negative, because we have all negative values, so that way I will consider here negative. And you just put in the decreasing or like minus 220, minus 200. The Because I have taken 20 degree gap between these two values, just because I have to adjust this all value minimum and maximum. So 220 uh, values, minus 180 degree, minus 160, minus 140, minus 120, minus 100, and minus 80. Now at from this table we see that at frequency omega is equal to 1 we have 95.7 degree, at 5 we have 116.5 degree. So look at here, at 1 we have substituted approx 95.7, that means 96 degree, because this is the 100 and each a small block has a difference of 4. So that this is nothing but 96 degree approx. So at 5, that means 1 2 3 4 5, 5, the angle is approximately 116 degree, and at 10 degree we have the angle approximately approximate to 136 degree. Similarly at 20 30 40 50 we have the angle approximate to 172 degree, and at 100 it is near about 180 degree, and 200 again we have the angle 188 degree, minus 188 degree, and at 220 approximately 206 minus 206 degree. And this graph has to be drawn in a free hand. We are not using a scale here, just because the margin will be increased. That's why we will uh, align this all the dotted line with the free hand. Okay, so now this yellow, I mean green line is nothing but phase plot, and this blue line is magnitude plot. I mean a same graph sheet, semi-log sheet, we have plotted magnitude plot as well as phase plot. Now this complete graph is nothing but bode plot. So in now there's one more or one or two more terms is there, that is phase, how to find out the phase margin and gain margin. So this 0 dB line I have drawn a red line, and minus 180 degree line here, minus 180 degree line I have drawn with a red line. So because while finding out the phase margin and gain margin, these two lines are very important. So in just I am giving a brief overview. This 0 degree line where it intersects the gain plot, it is nothing but gain crossover frequency, and the minus 180 degree line where it crosses the phase plot, it is called phase crossover frequency. Got clear? And now this point where this 0 dB line crosses the gain um, plot or magnitude plot, this is called gain crossover frequency. Now you just draw a line in such a way that this should intersect the phase plot. So the point where it intersects is the difference between minus 180 degree line to this point is nothing but phase margin. Now opposite to that, minus 180 degree line crosses this one is phase crossover frequency. Now draw this line in a upwards in a such a way that it intersect gain margin somewhere. So the difference between 0 dB to the point where it intersect is nothing but gain margin, because in this case the gain crossover frequency and phase crossover frequency align together. That's why in the both the cases gain margin and phase margin are 0 degree. So that's why because it overlaps gain crossover frequency and phase crossover frequency each other. Thanks for watching, and in next session we'll continue further.